Let's go through LeetCode 225. Implement stack, use queues. For this question, if it didn't say using queues, you can use any structure to implement a stack. For example, linked list, for example, array. And to implement that, both are not difficult. And to implement use queues, we can use two queues, Q1, Q2, and if there is an element coming, we just push offer the X to Q1. If there is for the pop or top, is that for example there is x2, x3. For example, there is size, right? So we just put the size -1 to Q2, just to be here, Q1, Q2, and then we just pop. That will be Q3, right? Pick is just we have a Q pick. So implement should be not hard. And actually, when we think about that, even Q2, this kind of data structure is not necessary. For our pick or pop, we just move the Q1, X1, X2, move out, just append, push into it, the same queue again. So that will be X3, X1, X2, right? So it's a one queue will be enough. And so if we pop, that is X3, PP also for this one, pop this will get this out. So I think the implementation will be kind of straightforward. One of the things we need to consider about is for moving those kind of elements, that size -1 element from the queue left part to the end part. Where should we move it? We can move it on the push part. In this case, the push will be an ON time operations, but the pop and top will be O1 time operations. And we can also, when we're trying to pop or top, before the pop and top, we can also, for this kind of red line, move it to the end of the queue to add a logic here. In this case, every push will be O1 operation, but the pop and the top will be ON time complexity. So when we think about the implementations, we should clarify whether this is write heavy or read heavy, right? So we can consider this the read. If it's read heavy, we have this kind of move in here. If it is write heavy, we just have the move every time when we want to have this one to be O1 and just move in this kind of part. So let's write code for it. Q. Okay, have this one here. And the empty is also very easy. We can kill this empty. For push, the first thing is that we need to have the queue offer X. So let's assume this is an read heavy system, right? So we need to put the size -1 element, offer the size element -1 element to the queue again. Every time we push, we'll say int int I equals 0, I smaller than q dot size -1, right? I plus will offer q dot for the pop and top, that will also be easy for empty -1. Then return q offer and for the top, just return q dot p. Right. So q offer sorry. So if this is write heavy, that means if the push being called multiple times, then we can move this one like here, right? There's something like here. And so this depends on what kind of queue is using. That is also straightforward. We cannot get every operation to be O1. If push is ON, then we can have pop and top to be O1. If pop and top ON, we can have the push to be O1 operation. Empty is O1, right?